Hi class, welcome to our video lesson for nature of solutions given the reduced row echelon form. So before you watch this video, I hope you know how to reduce a matrix into its RREF. So let's have this example. So if we are to solve for the reduced row echelon form of this linear system, I have already solved it. So after rewriting it into an augmented matrix, I added, I multiplied the first row by -1 and added it to row 2. And then I got that. So that's the new second row in order to eliminate or to make the first coefficient here on the second row 0. And then from there, um, I added the inverse or the opposite of row 2 plus row 3. Okay. So this is my whole process. I know you can have your own process. We don't have a unique or we don't have one unique solution for getting the RREF. You can um, have multiple ways of getting it. So at the end, I got this reduced row echelon form. So each leading term is 1, as you can see here. If we have a leading 1, then the other columns must have 0 in it. So this is the reduced row echelon form. So when we rewrite this, so once we rewrite this in back to an equation, so this is simply W is equal to 1 based on what we have here. And then here we have Y plus 3 over 2Z equals 2. And then here we have x minus 5z equals -4. So we know already that w is equal to 1. And as you can see here, we need to give the values for x, y, z, and w. So for x, we can rewrite x in terms of z, as we can see here. So x, you just need to transpose this. So x is equal to 5z minus 4. Okay, and then for the other one here, for y, we can also rewrite y in terms of z. Oh, 5z. Okay, okay. So transposing this, so we know that y is equal to 2 minus 3 over 2z. We don't have a value for z, so z can be any real number, and we don't have any contradictions for that. And now to w, we just have one unique value, which is 1. Okay, so to write our final answer is the solution set where we have um, x is 5z minus 4, and then y is 2 minus 3 over 2z, and then z is z. So let's just put it there, and then w is 1. So that's our solution set where z is equal to any real number since we don't have a contradiction. So that means we have infinitely many solutions. So infinitely many solutions as long as it follows these criteria. Okay? So a linear or a system of linear equations can have three types of solutions, as we've discussed also in junior high school. So a system can be consistent, dependent, or independent. So when we say inconsistent, we have no solution. So that's empty set. Dependent if it has infinitely many solutions, just like what we have here in uh the system has infinitely many solutions. And then lastly, independent if it has one unique solution, just like what we had in the earlier examples for solving linear systems. So how do we know that the type of solution given the reduced row echelon form? So it's a system is inconsistent if there exists a row wherein everything is zero, all the coefficients is zero, but the value augmented to it, or the constant value is not equal to zero. Okay. So for example, if we have zero, 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 and then the value here is 5. So in one of the rows. So that means if we write it into an equation, if we have 0x plus 0y plus 0z plus 0w, that's somehow equal to a non-zero value, which is impossible. So that's why we have an inconsistent system. Okay. Next. So again, for inconsistent, we don't have any solution. So you can draw it as an empty set. Okay. Dependent, if the reduced row echelon form of the augmented matrix has no contradictory rows, but at least one variable column lacks a leading one, then the system is dependent. So that means we have infinitely many variables. So we followed everything, but one of the columns or the variables doesn't have a leading one into it. So that means that's dependent. So the variable corresponding to such a column is what we call a free variable. So for this example, so this is an example of a dependent system because the variable z doesn't have a leading one. So z is our free variable. And then lastly, an independent system. This is a system where we have one unique solution. So we don't have any contradictory rows. Every variable column contains a leading one. Therefore, the system is consistent and has a unique solution. Okay. Oh, sorry. Infinitely many solutions here. And then here we have one unique solution. So let's look at some of the examples that we have here of the RREFs, and let's identify the type of linear system that we have. So here, we don't have any contradictory rows. So it's not inconsistent. So we have inconsistent, dependent, and independent. Okay. So you can pause the video if you want to try to answer. So again, it's not inconsistent because we don't have a contradictory row. Um, it is not dependent because every column here has a leading one. So that means it's not dependent, therefore it is independent. So now let's look at P. So we have a contradictory row. All variables are zero, but are multiplied to zero, but the sum is a non-zero number. So that means it is inconsistent. And then lastly, if we look at this, so we can see that we don't have any contradictory rows. Let's look at the columns. So this column has a leading one, this column has a leading one, but the last column doesn't have a leading one. So that means it is independent. Okay? So this means we have infinitely many solutions. This one doesn't have a solution, and then this one has one unique solution. So you may also try to solve this one using the systems, or you can check the values, and then from there you can solve for the systems. Okay? So if you have any questions, please feel free to message me. If you need more examples, you may also message me. Okay, that's it for this video.